So yesterday we talked about translations. That's what you just took a quiz on is translations. Now we're talking about reflections. It is still what's called rigid motion. So we're not changing the size, shape, or angle measures when we are reflecting something. We are just simply kind of like a mirror, moving it over a line. All right, whether that line is the y-axis, x-axis, some other line, you are just moving it so it's like a mirror image on each side. We have reflections are mirror images. So I'm just going to kind of help you find the important stuff here. So mirror image, and it is directly opposite its line of reflection. So both figures should be the same shape and size. Lengths have not changed, angle measures have not changed. And when a figure is moved to a different location, like I said, without changing its size or shape, that is rigid motion. When a figure is reflected, all points along each segment are reflected. So if there is a point that lies in between A and B, it'll still lie between A and B in the reflected image. All right, so it keeps or preserves collinearity. All right, that's the important one. Preserves collinearity and betweenness of points, just like with translated figures. Also, if there's a line of symmetry in the pre-image, it will exist in the second. All right. So here's an example of a reflection. All right, notice that it is a mirror image, just like your hands are mirror images of each other. But notice that the orientation of the two figures are different. So in this first one, we read it A, B, C, D. The points go counterclockwise, meaning they go towards the left, the way that you read them. But the reflected image will, even though it's not read the same way, like it would be read C, D, A, B, we still name it A prime, B prime, C prime, D prime. All right, just to keep it corresponding in the proper order. So even though they're listed clockwise in the reflected image, you just still name it along like the way that it is originally. So and we're going to show you kind of like a series of rules. So just kind of bear with me. It's not a whole lot of writing that you have to do, but what I would write is what I'll write up here. So anytime we're talking about reflections across the x-axis, the rule is always xy to x comma negative y. All right, so like translations have rules. That's what you just practiced and did your quiz on. Translations can have like really unique rules, but reflections have really specific rules. So if it's reflected across the x-axis, then you know to use this rule. And you get to use your notes, so make sure you're just picking the right rule. So reflected across the x-axis would be your horizontal or vertical axis. Your horizontal axis. So here's my horizontal axis that this is being reflected over. Right, so make sure we're looking at the right axis to use the right rule. because we're just flipping it across the x-axis, the x values should still be the same. Right? So like if looking at this pointy looking one, C to C prime, they have the same x values. But notice that the sign on the y values change because you're going on a different side of the y-axis. All right, but the x values stay the same. So here's that rule again. I just wrote it up towards the top so you can find it easier on your quiz. But that works for all the points. All right, x values stay the same for all of them. Y values, you just switch the sign. Questions about that? All right, moving right along then. If I'm talking about reflections for the y-axis, the rule is down here, but I'm going to write it towards the top. That rule is always xy, comma, negative xy. All right, always. So the y-axis, that's your vertical axis. So the y values should stay the same, and only the x value changes. So I'm going to highlight the y-axis, should be right down the middle, your vertical axis. And notice that these shapes do follow this rule. When I go from C to C prime, axis, they're still the same like base number, they just have different signs, right? But the y stay exactly the same. All right, questions about that one? So now we have where the line is y equal to x. So if you don't recognize that line, it's where you have a slope of 1 and a y-intercept of 0. But normally when it's 1x, you don't write the 1, you just leave it as x. And normally when we write plus 0, we don't leave that part on there because x plus 0 is just x, right? That's why it just says y equals x. Here's the answer. If you have questions, let me know. Like some of them, if you pick the right one, even if they didn't show work, I full points. And then some of them like they needed to show work. Okay, so let me ask you a question. All right. So that line is drawn there in green, but I'm going to highlight it so that you can see it as well. So like I said, it has a y-intercept of 0. Right, crosses the y-axis at the 0 mark. And it's rise over run is 1 over 1. All right, that's a really common line in geometry, so just kind of memorize that line. So that's y equals to x. So if you have something reflected over that line, what you have to do is follow this rule right here that I'll highlight and I'll also write at the top. So the rule is always xy to yx. So we're just flipping. You're not changing the sign of any of us. We're just putting the y in the x spot and the x in the y spot. All right, so just like in this picture down here, this c value is -2, 5. What is c prime going to be? Following this rule. What was the original y value? You guys need to start going to the restroom only on breaks. All right, so what is the original y value? Right, all right, if you get it wrong, tell me what the original y value is. That is my original x value. So my original y value then is 5. Right, and then since my original x value is -2, it now goes in this spot. Right, you see how we're just switching the order? Right, that's all we're doing to these. All right, questions? So if we're looking at b prime, or the original b for this one, it's -6, 3, then what would b prime be? Following this rule. 3, -6. Right? So next one. Now we have for horizontal and vertical lines. So these ones can be, like, if there's an infinite number of horizontal and vertical lines that you can plug. All right, because it's just anything on the coordinate plane that is vertical or horizontal, like these ones. I probably should have highlighted those. So they can be here, they can be here, they can be anywhere. In order to figure out what that line is called, you just use your slope rules and things like that. So for this one, it is labeled for us, but you could either memorize that all vertical lines will be x equal to something, you can do that. And you can remember that all horizontal lines are all y equal to something. For these ones, they're like a little weird, right? Because normally it's like y equals mx plus b. For these ones, I just think about like the undefined slope. That's why it looks weird. And it's also drawing a line where all the x values are the same. So all these x values are 1 or -1. All right, so any point that I pick off of that line has a x value of -1. So that's why we call that line x equals to -1. For this one, y equal to +1. Notice it has no slope, it has no rise. And it does have a y-intercept of 1. All right, also on this entire line, all of the y values are 1. All right, and the reason why I'm making you learn that is because I know on your quiz it says reflect this image over where x equals 2. Or reflect this image over where y equals 7. All right, so you have to know where that would be on your questions on how we figured that out. Now for the rule, it's not going to be the same for all of the points. So when you're just trying to figure out how to reflect it, what you're going to do is just find the distance. Let me highlight that. Find the distance for each point in the polygon before finding each corresponding point. So in the first example, if point C is 1, 2, 3 spaces away from the line of reflection, then C prime also needs to be 3 spaces away from the line of reflection. So that's 1, 2, 3. If point B is 1, 2, 3, 4, 5, 6 away from the line of reflection, then so does point B prime. It also has to be 6 spaces away, and it is. So it varies for each point. Just match them up. Make sure that point A is 1 space away from the line of reflection, and A prime is 1 away from the line of reflection. Same with these ones. Now the line of reflection is horizontal, but for these ones, you're still just out. All right, so C is, sorry, I wrote that ugly. 1, 2 away. Well, C prime has to be 2 away. All right, questions, comments? All right. So I guess to sum it up like we did for the other ones is count for each point. All right. So here's the first example, and all the first 5 examples are for the same hexagon or pentagon, sorry. It's for the same pentagon. It's just asking you to do different things in each example. So first we're going to reflect it across the x-axis. So where is the x-axis on this picture? Use your descriptive words, or use like a hand signal. All right, it's the line that goes horizontal, right? And it's this big line. So my x-axis is right here. If I'm reflecting it across the x-axis, there's a specific rule that we use for that. What rule is it? Flip back to when we did it, or when we went over the rule earlier. Do the x values stay the same? Yes. Do the y values change? No. Yes. What changes about them? They become negative. All right. So you can just look at the rule, or you can just kind of think about it. If I'm flipping it over the x-axis, the x values should still be the same, but now the y values are different. All right. So if h is -4, 5, then what's going to be my h prime? Following this rule. -4, -5. Good. Because the x stays the same according to the rule, but the y flips signs. And then if I were to graph that right now, it would be right here is where h prime is. All right, what is the coordinate for O, like the original O? -2, 3. So then O prime would be -2, -3. All right, so -2, -3. what is the original u over here? -3, 1. So then u prime would be good. -3, -1. I'm not sure if this is just really easy or if only one person. All right, so let's do s prime. What was the original s? Good, so then s prime should be good. And then e prime, well, what's the original e? -6, 3. So then e prime should be good. And then plotting that, we are down here. And does the shape look just like the original? Just a mirror image of it? All right, yes, except I kind of draw my lines a little wonky, but it should be a mirror image just flip. All right, the quiz question could say, what is e prime only? Or it might ask you to draw it, or it might ask you for all the coordinates. But that's how you find it, is just by following the rule that's in your notes. Right? Questions about this one? All right, I'll let you guys go on a 15-minute break right now, so come back at 12:31. And then I won't let you go into the restroom again until 1:31. So if you need to use the restroom, use it now. So for this one, we're reflecting across the y-axis. You need to know where the y-axis is. So where would the y-axis be? Describe it. Show me with your arm. All right, the vertical axis. Good. So this one right here is your y-axis. So to reflect this pentagon over the y-axis, it needs to look like a mirror image. Flip over it. But since there's a distinct rule that we were given, that rule is always going to be the x values switch signs or anything. All right, they should, because they would be over here somewhere, and these x values are different signs over here. So yeah, it should be -x. Do the y values change? No, they stay the same. So the rule is written for you, and yeah, you can get to use your notes if you have to memorize it. No, but that's just showing you why that rule is the way it is. All right, so the coordinates for HOUSC are the same as before. So I'm going to just copy those ones over. All right, H was -4, 5. O was -2, 3. U was -3, 1. S was -5, 1. And E is -6, 3. All right, so those are all my originals that we already said before. Now we're looking for our new H prime, O prime. So starting with the H, if my original was -4, 5, and we're using this rule right here, what's my new coordinate? Good, it should be 4, 5. All right, so this minus sign just means you're switching the sign. Since it's already negative, now we're making it positive. All right, and the y value stays the same. So my H prime should be right here at 4, 5. Make sense? If my original O prime was -2, 3, then what, or not my O prime, but my original O was -2, 3, what's my new O? 2, 3, good. So 2 up 3 is my O prime. On your own paper, real quick, find U prime, S prime, and E prime, using that same rule. Right, so -x comma y is our rule for over the y-axis. All right, what is my U prime coordinate? Good, 3, 1. S prime should be, and E prime should be good. If you did not get that, just kind of double check. See where you went wrong. All right, so just flipping the sign on the X values, keeping the Y value the same. All right, and then plot your coordinates. And then what you should notice is the mirror image. All right, so that's our reflection over the y-axis. So you might have a coordinate plane on your quiz, you might not. It might just ask you, given this picture, what's U prime going to be, and then you only have to find one of them. All right, so that's why we have this rule here, so it makes it easy. Good. All right, y equal to x is the next one. So that one, does it have a specific rule? It does have a rule. And that rule is that we just switch the order on that one. All right, so this one has a specific rule. Also, for your reference, where is the line y-x? Like, where does it go in the graph? Or y equals x, my bad. All right, it's a diagonal. And it looks something like this, where there is a slope of 1 and the y-intercept is 0, right? So that's what this is. So just so you know, we're flipping it over this line and we're using this rule to do that. So real quick, I'm just gonna fill in what those coordinates were that we already knew from the first examples. Oops, that's not. So H is -4, 5, O is negative 2, 3. U is negative 3, 1. S is negative 5, 1. And E is negative 6, 3. All right, what's my H prime going to be? Thank you, Brianna. 5, negative 4. Someone else, what's my O prime going to be? 3, negative 2. Thank you. Are we seeing the pattern? So then that would make U prime 1, negative 3. S prime would be 1, negative 5. And E prime would be 3, negative 6. All right. So flipping them according to that rule, I'll write the rule here in the corner. I'm going to slow down. Can't see it anymore. All right, but here's my new coordinates. If I plot them, then we get our reflected image. So 5, negative 4 is down here. 3, negative 2. 1, negative 3. S prime would be down here. And E prime down here. And it might be hard to see that it's a mirror image. Whenever it's over this line, it's always kind of hard to see. But it is. And the closest one to it originally was U, so the closest one to it should be U prime. And then followed by S O prime. So it does mirror image now. Questions? All right. So those first 3 examples, I think, were like the easier ones because the rule is automatic, right? You just follow the rule, you don't even question it. The next 2 that we're going to do does require like a little more effort because you have to figure out where those 2 lines are. So starting with the line y equal to negative 2 right here. Basically, I need to draw a line where all of the y values equal negative 2. So would that be a horizontal line or a vertical line? Vertical should be horizontal. It's like the opposite of what you might think. So like, if I find negative 2 for my y value, right, so find it on your y-axis, it's down here. If I draw a horizontal line through it, all those y values will be negative 2. Does that make sense? Right, so right here is where my reflection will be. Try that again. All right. So anytime it's y equals, it's going to give you a horizontal line because that's what will give me where all the y values are negative 2. So if I need to reflect this pentagon over this line, there's no set rule for that, is there? Is there a set rule for that in your notes? Right? It should say that there's not a set rule that you have to count for every single point. All right, maybe you might find these ones easier. So like U going from here to to the line of reflection, how many spaces are we moving? All right, so that's going 3 spaces up to the line. 1, 2, 3. So in order to find the reflected one, I need to go 3 spaces after it. So 1, 2, 3. And that's U, so that's going to be U prime. I usually start with the ones that are close. All right, what about S? How many spaces away from the line is S? Good, also 3. So then after your line of reflection, go down 1, 2, 3. That's where S prime will go. Do the same with the other ones. So E goes down 5. Good. So count 5 spaces away from this line. And E goes here. All right, do that with H and O. I think you'll actually be a little off the graph. That's okay. But just kind of sketch where it would be for H and O. All right, and what you should get is a pentagon down here. Oops, I can't connect my dots. I'll just leave it like that. All right, then you connect your dots, you make your pentagon, and it is reflected, right? It's a mirror image, just now over a different line. A good quiz question might be, if pentagon house is reflected over y equals -2, then what is S prime? Right, am I not asking for all of that? So if I ask you what is S prime, then what would you say? It's that X value of -5 and Y value of -5. All right, what about H prime? What's that XY value? I know it's like off a little bit, but that X value should be -4 and the Y value is -9. O primed is -2, -7. O U. U primed is -3, -5. And E primed is -6, -7. All right, so practicing labeling them. Questions? All right, and then if you notice, like if you look back at what these original coordinates were, they don't really follow a specific pattern for each one like the other examples that we did. So that's why you have to actually count it like we did here. All right? Would you guys like to try the next one on your own, the line equal to x equal to 1? I think you guys got it. I'll kind of help you out. For this one, for x equal to 1, is that line horizontal or vertical? Good. Anytime it's x equals, it's going to be a vertical line. where all the x values are 1. Alright, so think in your head where that might be. Alright, all the x values need to be 1. I should probably look at my x-axis, find 1, and draw a vertical line through there. Alright, that's your line of reflection at x equals 1. Alright, so do the same thing we did in the last one. There's no fixed rule. You have to count each point to get that mirror image. So I'll give you like 1 minute. All right, so compare your answer to what we have up here. So it's reflected across the line where x equals 1. So it should look like this. And I wrote down, hold on. I wrote down the coordinates for the new image. All right, so again, for these ones, you have to count. So like O is 1, 2, 3 spaces away, so you count 1, 2, 3 spaces on the other side. The H is 1, 2, 3, 4, 5 spaces away on one side, so it has to be 5 spaces away on the other side. And that's pretty much true for all of the other ones. They should be the same amount of distance away, but the other ones have fixed rules. Questions? All right, you need to stay on this one longer. Anyone? Go for that. All right, so now top of page 7, now we have examples without the coordinate plane. These ones I kind of like better, I don't know why, but we'll try them out. We have the triangle PQR is graphed on a coordinate plane with vertices at the following ordered pairs. So I guess it's less having to figure out what the original coordinates were. If triangle PQR is reflected across the x-axis to create triangle P prime, Q prime, R prime, what are the ordered pairs of each vertex in the new triangle? All right, so what is the important part here that tells us what we need to do? Or what rule we need to follow? All right, exactly. Where it's reflected across of can tell us what rule to use. So across the x-axis will be the same rule that we always use when it's across the x-axis. So how does that coordinate change? All right, x stays the same and y changes, is that correct? Right, that is correct. So then if our original coordinates over here are listed for us already, then all we have to do is apply that rule. So then P primed should be what? -4, -6. Again, notice the x stays the same, the y changes sign. Q prime should then be -2, -3, and R prime should be. All right, makes sense. Any questions? All right, and then that's it. These are my answers. I can stop there. I've answered the question. All right. I'll let you guys try the next one completely on your own. So it says you try number 2, hexagon JKLMNO. So try number 2. I'll leave this up as an example. For the you try number 2, that one does have a specific rule because it says reflected across the y-axis, which matches one of the rules we talked about. All right, so when you're flipping over that vertical axis, the x values should change, right? Because it's different on each side of that line. But the y values should stay the same. Right? So if you didn't get those same answers, make that correction. All right, but notice all the y values match the original y values from the problem. All the x values just switch signs. So if it was negative to begin with, it should become positive. If it was positive to begin with, it should become negative. Right? It's like multiplying that number by negative 1. Right? So then you guys can try number 3. So first, read it, see if there's a specific rule you can use and apply it. Give you another minute for you try number 3. All right, so after reflecting across the line y equal to x, that does match one of our fixed rules. So here's that rule for your reference. So when it's the y equal to x line that we're reflecting over, you're just switching the order. All right, you don't switch the signs at all, just the order that they're placed in. So if the original was 2,8, then the reflected is 8,2. Or if the original was 0,5, the reflected is 5,0. Right? Questions about that? All right, these next few slides are kind of just illustrating the reflection, not so much problem solving, so just bear with me. I'll kind of point out the important parts that you should highlight. So we have, looking at figure 1, we have a hexagon reflected on the coordinate grid using this rule. All right, it tells us the rule. Let's pretend it didn't tell us that it's reflected across the x-axis. If it says like what rule was used, then, or where was it reflected according to this rule, you would know that it's across the x-axis, right? So all the x coordinates do not change. Only the y coordinates change value, and that becomes negative, which we've already kind of talked about. But here it is illustrated with some vectors. All right, you'll see that they end up being the same distance away from the line of reflection. So A is 1 spot away from the line of reflection. D is 3 spots away, so D prime is also 3 spots away from the x-axis. And all it's really wanting you to sum up from this one is, do the hexagons change like size or shape? Is there a difference in size or shape from the first one to the second one? So that's the other important part. So reflections do not alter size or shape. So would you say that these hexagons are congruent? Are they identical to each other in side lengths and angle measurements? Should be yes, because reflections do not alter size or shape, so these are congruent. Right. Scrolling down a little bit. I'm able to. All right, so figure 2. We have a hexagon reflected across the y-axis. So notice that the rule for that we already discussed, but if you had to come up with the rule, you see that the x values change, the y values do not. All right, that was pretty straightforward. Still congruent shapes. Figure 3, reflected over the line y equal to x. If that wasn't there to show you, I know I wrote it in, you should be able to recognize it visually. Start recognizing where y equal to x is would be on the graph. Just like how you know where the x-axis and y-axis are. So the rule we've already discussed, kind of reiterating that rule, xy becomes yx. And that's showing you how it changed. And notice in this example, as the shape goes through the line, they kind of like overlap each other, right? It's still a reflection over this axis. I know it's like that. Questions on this one? All right, so let's go back to the normal slide. All right, so we have parallelogram FGHI and its reflection F prime, D prime, and so on are shown below. What is the line of reflection between the parallelograms? All right, so is this one of the 3 fixed rules? Did it reflect evenly over the x-axis, y-axis, or y equals x? Yes? Hold on to that thought for a second. All right, so because it's not the same distance away on each side of the y-axis, like right here, we can't say it's a reflection over the y-axis. It obviously didn't reflect over the x-axis or the line y equals x. So if we had to figure out the rule, and we know that they should be an equal distance away from the reflection line, then all I have to do is count the distance from each corresponding point. Right, so how many spaces away is G from G prime? 8. And since the line of reflection should be right down the middle, then what's half of 8? So my line of reflection should be it should be down here. And what's the equation for that line? Something equal to 2, right? Should be the x values all equal to 2 at that line. So since this goes here, they're both 4 spaces away. The line of reflection goes where x is equal to 2. Does that make sense? And you can double check it by testing out all the other points, make sure that they're the same distance away. Like how far away is H from the line? Right, should be 5 spaces away. Is H prime also 5 spaces away? Right, yes. So all this question asks is what's the line of reflection? So my line of reflection is where X is equal to 2. Make sense? So when in doubt, to find the line of reflection, figure out the distance between them and divide it by 2. And see what equation matches that area. All right, then practice 2, 3, 4, and 5. Or no, practice 2, 3, and 4. We kind of already did. I don't want to like talk it to death. So let's look at practice number 5 right now. All right, feel free to try those other examples. I will post the notes in the Google Classroom and you can see those solutions. But we've kind of already done ones just like those. So let's look at practice 5. We have triangle ABC transformed to A prime, B prime, C prime. What 2 transformations apply to triangle ABC to create A prime, B prime, C prime? So it wasn't just reflected. What else happened to it? Was it rotated? I haven't talked about rotations yet, so I don't think it's going to be that one. Translated, good. So it was translated and reflected. All right, but we do have to be a little bit more specific. We have to say the rules that it translated by and that it reflected by. So let's start with reflected. All right, where did it reflect over, do you think? What position on the graph? Did it reflect over the x-axis? It reflected over the y-axis. All right, so I'm going to reflect this image over here to get my reflected image, so over the y-axis, and then I'll figure out what it translated by. So really, I probably should have put translated down here, because we had to have reflected it first. So reflect this over the y-axis. So if C is 1, 2, 3 spots away from the y-axis, it needs to be 3 spots away on the other side. And we'll call it C1 for right now. All right, and then do the same for the other points. If B is 1, 2, 3, 4, 5, 6 spots away, then it should be 6 spots away on the other side. All right, so this is what my triangle looks like after just reflecting it across the y-axis. How can I get it from here to here? We did say we translated that triangle, but by how much? So for example, we can just look at the A's and compare those. How much to the left or right did I have to move this A1? All right, I moved it 1 to the left. Is that going to be positive or negative movement if I'm going to the left? So it should be -1. So just like how we wrote the rules for translations, like the one you took a quiz on and did really well on, should be x -1 for the translated rule. And then how much upward did it move from A1 to A prime? All right, let's see. Sorry, can't draw a straight line. 1, 2, 3, 4, 5, 6. Good. And is that positive or negative movement? So y plus 6. So it's reflected over the y-axis and translated by the rule x -1, comma y plus 6. All right, questions about that? So if I were confused on my quiz for this, which you'll take on Monday, so try not to forget everything. If I were taking the quiz and I was stuck, I didn't know what transformations I could have possibly done, I'd probably test out my answer options. Because it is multiple choice for the most part. So I would test out my answer option, see if reflecting over the y-axis and translating by that rule gives me this resulting triangle. All right, questions, comments? So you picked up a packet on the way in, the 2.02 reflections packet. For that one, you will submit your answers on the Google form. And you'll keep the packet, you'll get points by submitting it on that Google form. Questions? All right, at 1:30, I'll let everyone go on break, whether you're finished with the packet or not, and then I'll give you more time after the break to